Hi, this is Subhashini and Shreya sitting under the desk. And today we're going to record how to do linear regression using Excel and then use the same data set to do linear regression with Python. So this is the data set. There is an organization which is looking to understand what drives job satisfaction amongst its employees. Now, the data that is given to us has employee ID, department, tenure, that is the number of years the employee has been in service within that particular company, age, job satisfaction score. So the company did run an engagement survey to understand how satisfied the employee was in his job, and then the training hours in the past year, which is the number of hours that training was provided to each employee. You will notice that this data set has two sheets. There is sheet 1 with just 20 rows of data of employees, and then sheet 2 which has some slightly larger data set. So we'll work on sheet 1 and then we're going to take the outcome and rerun it on sheet 2. So I create this particular Excel sheet in this file and I name it as summary. Here, what have I done? I've actually put down the DECOVA and I process of problem solving so that it's easy for me to track my project. So when we want to define the problem statement, what do we know? That the company wants to know what influences the job satisfaction score for the employees. Okay, so this is the problem that we are out here to solve. And what is the data that we have? So we are looking at sheet 1, the data with 20 rows of data across different departments, right? So this is not a singular department data. So this is the problem statement. This is the definition of the data. Now, when we look at collecting the data, do we have some extra data to append into it? No. So there is no extra data. Okay, so we have sheet 1 of data. And then when we look at organizing the data, what are the things we look at? We look at missing values, outliers, and then dummy variables and derived variables. So let's just make space to write down our observations for this. So dummy variables and derived variables. I think every one of you knows this. Missing value is, of course, where the data is missing. Outliers are unusual values. Dummy variables are 0, 1 variables, which help us create number variables out of non-numeric variables. Now here in this data, what is the non-numeric variable we have? We have department, and department has marketing, sales, finance, operations, IT. So we will make dummy variables for this department, right? Variable. And derived variables is variables which are derived from either date or other number variables. For example, age is today's date minus the date of birth. Okay. So these are the things that we're going to focus on now. So the first thing we do is we create a copy of the data set. So I just go here and I say move or copy, create a copy. Okay. Now in this, what we want to do is to understand the missing values. So how do we know that? We do the count A is equal to, or we can do count blank. Okay. So whichever works for you. You can use any of these formulas. So here we go. So we can see there are no blank rows. So there are no missing values. Okay. Now let's look at, so let's write the comment here. Okay. Let's look at outliers. And when we look at the job satisfaction score, which is our Y variable, so whatever is the problem statement within the data, it's called the Y variable. Okay. And everything else is the X variables. So you can have multiple X's. Okay, so the first place to look for an outlier is in the Y variable. And when we look at it, we can see that the numbers are very restricted to values between 5 and 9 only. So there can be no outliers in the Y variable. Okay. Do we want to look at training hours in the past year, etc., and see if there are some outliers, some very large values or very small values? We don't want to do that in this data set because this data itself is so small. So what I do here is go and say that there are no outliers. Y is in a specific range. And for dummy variables, we know that the only non-numeric variable is department. So we'll do the dummy variable for department. Derived variables are not really required. So let's look at it. How do we create dummy variables? So the first thing to do is to just quickly run a pivot over here. You know, pivot tables help you summarize your data. So I will just run this pivot here and here you go. I'll just take out departments over here. So you can see over here, these are the departments available in the data. I pick them up and in this data set, I do pay special and transpose. Very easy. So these are the departments that we have: finance, IT, marketing, operations, and sales. Now what we want to do is for each employee, we want to be able to say, does this person belong to finance, IT, marketing, operations, or sales? So let's go and put the formula is equal to if this value is the same as this value, then I will say yes, else I'll say no. Okay. So this guy is not in finance. Okay. You will notice I'm putting the dollar mark here to make it easy for me to drag the formula across and not have to rewrite it for every cell. So yes, this person belongs to the marketing department. So the formula is working fine. It's showing me this employee is from the marketing department and not from any other department. So I can take this formula and just run it through. Okay, so how do I know that this formula is working fine? I just eyeball it. So this guy is coming out in sales. Let's see. Yes. So the formula is working fine. Now I have all my data in numeric format. Now, what are my X variables therefore? So department is definitely the variable which is uh, now not going to be used directly in the analysis. We have made the dummy variables for it. We don't need to make derived variables for any other values. And we can go ahead and do the analysis. So what do? I can just make a copy of this data and then start with the analysis. So I've made a copy of the sheet 2 again. Okay. And now what do I want to do is I want to remove the formulas which I have used in creating the dummy variables and actually remove these two. This doesn't help either. Okay. So what do I get? I get the Y variable, which I put into the A column. I've rearranged my data and we are ready to do the visualization. So let's just understand how the visualization works. I will take an insert pivot table from the data sheet. I always like using the classic pivot table layout. It allows me to drag and drop things. Okay. And what do I do? I actually want to look at the job satisfaction score range, okay, and perhaps the average tenure in years, okay. I'd like to make a visualization on this. Now, this is showing me the sum of tenures. I can actually just go to the value field setting and put it as average tenures. Okay. So what do I see? That for 5 score, the average tenure is 3 years. And for 9 score, the average tenure is something like a 6.75 years. So definitely what seems to be that the tenure seems to go up. So the people who actually stay with this organization seem to like it more. Okay, which is intuitive. That is how it should be. So I can go here into insert and actually insert a chart. Okay, and in this pivot table area itself. Okay, remove the blank and I can do average 10. Okay. So this is the average tenure. Now you might say, can I not see the average satisfaction score by tenure? Yes, I could have done that too. So if I just change this in the pivot table, it will allow me to see this a bit differently. Let's see how to do this. Okay. So what are we saying? We want to take the tenure and put it here and put the average of the job satisfaction here. Okay. So here average tenure, this I will remove the field. Okay. This is and put the job satisfaction in the value field. Okay. Sum of job satisfaction, it's much better to pick up the average of job satisfaction. Okay. So here what do we find? That, just the reverse happens. Okay. Now this is not the average tenure. This is the average job satisfaction. Okay. Okay. And what do we notice? That the tenure increases and the job satisfaction also seems to go up. How do I know that? I can actually add a trend line here. Okay. And it will tell me the overall trend of whatever I'm seeing. Okay. So just an example of how you can plot and visualize your data. I could call this a visualization pivot, right? So I'm just renaming this sheet. Okay. Now this is one example. Could I have done anything else over here? Yes, I could have. So I'll see the field list and I'll put the tenured age and tenure up and I'll pull out the age over here. So what do I see again? Simple. Okay. Average job satisfaction seems to increase with age, right? So this is an example of how quickly you can do certain visualizations and get started on your project. Okay. So here in the summary, I could actually write this. Pivot sheet. Okay. So here it is. Let's do the analysis, statistical analysis. Now, what is our aim? We want to understand what drives job satisfaction score. So the first analysis we will do will be called correlation. It will tell us the relationship between job satisfaction and all the other variables in this data set. After that, we will create a linear regression. So let's go ahead and do that. Now you know that within the data tab, You have the data analysis tool pack. So we go ahead and we find out the correlation tab in the data analysis tool pack. Okay. And here you go. I have chosen the data labels in first row, and in a new worksheet, let the outcome be seen, right? So what do I get really? I get the job satisfaction score, and I get the correlations with the different values. Okay. So I will do some further processing to understand this a bit better. Job satisfaction with itself is very highly correlated, 100% correlated. What about with others? So I will find out the absolute values of the correlation, because correlation has plus and minus values, but in correlation, the plus and minus only shows direction, it doesn't show value. Okay, so here we go. Okay, this is the absolute values. If I want to understand this a bit easier, I'll just take it in percentages. It makes it easier for me to understand. This is not the is equal to absolute B12. Okay. So what do we get? These are the most highly correlated values, right? Tenure, age, and training hours. This is what really drives job satisfaction. These are the drivers of job satisfaction in this data. Okay. So what are the drivers? Which are the three most important variables? Tenure, age, and training hours. I'll go and put it in the summary slide, that this is what came out of, sorry, of the correlation. So I'll just shift all this stuff down. Okay. So tenure, age, and training hours have come out to be most highly correlated. Okay. Uh, then let's look at running the linear regression on the same data set. So I go to the data tab, data analysis, and here we get regression. Now, what is the y variable? We know what is the y variable here. What is the x variable? We know that too. Okay. There's labels in the top row at a 95% confidence. Okay. 95% accuracy. And we'd like all of this in a new worksheet. So here you go. This is the outcome of the regression. How good is the model? That's what we come to know from R square and adjusted R square. Okay. What is the accuracy of the model? How good is the model? Is it something you want to implement? Okay. So adjusted R square is showing 0.51, which is not really very high. So it is definitely not very high. It is not going to give us a very accurate value. But when we look at all these, okay, what do we understand? That regression is actually an iterative process. We can get a better and more improved result. Okay, I'll just rename this as reg 1 so we can track all our sheets. Okay, if we were to remove two things, IT and marketing, out of this data set, how did we conclude that? Look at the p values. What is p value? It is the level of confidence, right? So let's go back here. IT and marketing. I will just move it this side. On the left side, it is outside the value of or the area of doing the regression. So I go back to data analysis, and run a regression. Okay. We'll just change all these values. Now the y variable is in which column? It's in C column. Okay. And all the variables we want to consider is in D column. Okay. Every other value we've kept as the same, and in a different sheet, we can see that the outcome has come. Again, the values to look at is R square and adjusted R square, and we can see that the adjusted R square has improved as compared to the older regression. So here you can see here, I went back, it is 0.51, it has actually risen to 0.58. So I'm going to just rename it as Reg 2. What happens here? I can come and see what are the p values here. And if there is any other value which is highly correlated, okay, I should remove them. Okay, so here is one value which is very highly, which has a very high p value. Okay, and I might want to drop it from my next run of regression. So regression, linear regression especially, is an iterative process, and we will go through multiple iterations before we can come to that exact set of variables which are important, which can be used to exactly tell us the equation for job satisfaction. So here you go. I have done 4 iteration of the regression and stopped here. Why? Because I find that the R square value has actually gone down. Adjusted R square has gone up from 0.51 to 0.62. However, now we've come down to the to a set of 4 variables, and it doesn't make sense to reduce the number of variables furthermore. So we can assume that this is perhaps the best possible model that we can create out of this data. So since our aim here is not to really predict the job satisfaction score, rather what is our aim? To find out what are the factors which seem to most importantly affect job satisfaction score. So these are the 4 factors: the tenure, whether the person is in finance, operations, or sales. This combination actually seems to affect or seems to explain the high job satisfaction score of the people in this organization. Okay, so I'm going to put this into sort of into my summary so that I can conclude the project. Okay. Okay. So what is my insights? My insight is simple: a combination of tenure and departments being finance, operations, or sales influences job satisfaction score. Okay. So this is the insight. This is the conclusion of the project. So 3 things I'd like to just bring to your notice. One is it is important to follow some sort of a process to ensure you don't forget any step when you're doing a project. So DECOVA and I is a process which I follow in my teaching as well as in my consulting, and it has really worked out for me. It helps me do 2 things. It helps me first understand that what is the time that I might need for a project, depending on how many outliers, missing values, the fact that certain projects could be, would have larger data sets, more unclean data, etc. The second thing, it allows me to do a very clear presentation at the end of the project, okay, step by step to the audience that I have in mind, okay. And for me personally, in the middle of the project, I don't forget anything. The second part of it is that the analysis part to it, it is not important for every project. So there can be visualizations, create a report, create insight projects, which could be pure visualization or graphs and charts projects. You might not need to do analysis over here, but in case you do have to do analysis, I have found correlation and linear regression as the 2 most common statistical processes that are used. Okay. And it is very important as a data analyst for you to put down what is the conclusion or insights, because often the audience may not be able to really decipher what you are saying. So with this, I will close this video and take you through this same how to solve this data in a Python video. See you really soon.